Hi, I'm John Lamb, grade 10.
Hi, I'm Rachel Maurer, grade 12.
I am Madison Bright, and I am in 12th grade.
Abigail Brown, grade 11.
Evan Carneal, 11th grade, and this is our product.
So for this research, I worked alongside Rachel to develop the bandage, as well as the microbiology portion of the project, where I determined whether bioactive glass can be used as an antimicrobial.
My role in this product was to work on the mathematical portion in determining the measurements of the wound that were enabled in the app.
My role in this project was to help create the actual bandage itself and changing the chemical composition inside the bandage so that we could have a better overall product for patient care. My overall title for this project was the material scientist.
My part in this research was to work alongside John and develop the app and to work on connecting the 3D printer to the phone.
My role in this project was to develop an app that can measure a wound's proportions and display these proportions.
So for this research, I have mainly been working with a product called bioactive glass, and it is a product made of high purity chemicals found naturally in your body, and there are many different types of it. We worked specifically with borate-based Miragen. So there are three things that bioactive glass does. It is extremely absorbent, it is extremely sterile, and it heals cells where there is damaged tissue. And so I have been working with cell culturing on a fungus called Candida albicans, which causes yeast infections. And I have been testing borate-based bioactive glass to see if bioactive glass can be used as an antifungal. And with this research, I can then use my data to support that bioactive glass should be used in this bandage to prevent infections. So for the cell culturing, I tested a total of 3 types of bioactive glass. Each type had a different chemical composition. And I tested the 3 different types of bioactive glass against the Candida albicans fungus. And then to gather the data after the period of time that I let the cells incubate, I ran hemocytometer tests, spectrophotometer tests, live cell imaging, and fungal staining. And all of this data suggests that the bioactive glass would be an effective antifungal that could be used in this bandage.
My part in the project was to create a bandage that was perfect for each patient. Again, found through the dimensions and sent to the 3D printer so that I could find a way to make the perfect bandage. In our project, we wanted 5 different layers. The red being the fabric, the orange being the adhesive, and the last 3 of the black, the blue, and the green as the different bioactive glasses. Each bioactive glass has a different chemical composition that allows for better and faster healing. Each layer represents a different type of healing process, which allows faster healing but also no scarring at all. Again, as bioactive glass has those attributes, it is also antimicrobial, allowing a better way for the patient to get better medication so that their bandage can work better. Also, in addition to the bandage and making it, I also created my own adhesive. This adhesive is all natural and has no chemicals that are found in artificial glue. This allows us to label our product as natural and also better for the human body.
My role in this research was to calculate how a wound can be measured, measuring the surface area, the volume, the length, and the width. I did this by incorporating the app that John has created and using basic mathematical functions and calculations that we use in everyday algebra and scientific calculations.
My research in this project was to make an app that can measure the general dimensions of a wound and using Xcode, Apple software Xcode.
I worked with the 3D printer to ensure a stable connection between the app and the printer itself, and I also worked with replicas that we needed for our past research.
The future direction of our product is for large companies to invest in it and for it to be utilized in hospitals and for patient care worldwide.